Hey guys, welcome back to Algebra 2. Today we're going to be covering 1-6 and actually 1-7 in your workbook today because those two sections are so similar that we might as well cover them together. We're not going to do a ton from 1-7, so don't be worried when you're watching all the videos for 1-6, but they are all going to be together. The notes are going to be on page 41 in your workbook, and they're all about linear systems. So you've probably seen linear systems in the past. In this lesson, we are going to review a little bit of what you've done in the past, but also build onto it and push it a little bit further because this is Algebra 2, it's not Algebra 1 anymore. It's all about linear systems, and specifically linear systems of equations and inequalities. So you have a graph right here of a system of two linear equations. And the equations are written here, in case you were wondering what they were. A system of linear equations is a set of two or more equations, or it could be inequalities. It would be inequalities if these were less than or equal to, or greater than, or just greater than or equal to. But this brace right here kind of shows you that they are a system. Sometimes that brace will be there, sometimes it won't, so don't always look for it. And then a solution is the point or points which make all the equations or inequalities, whichever you have, true all at the same time. So sometimes these are called simultaneous equations because the word simultaneous means the solution is the one point that works for all equations simultaneously. Now, you've solved systems of equations probably in the past with three methods. Method one, which is traditionally taught first, is solving by graphing, which is why you see a picture of a graph here. So method one is solving by graphing, and when you're graphing a system of equations, you graph all the equations in the system, and then you look for the place where those graphs intersect. So that would be the solution. And the solution gives me an x and a y value that when I substitute into each equation, I get true statements. The second method of solving a system that you've probably done in the past is called substitution. Substitution is when you sub one equation in for another. And then the third method is called elimination. And we'll review substitution and elimination in just a minute. But there are some things you need to know about systems of equations because it's possible that your system has a solution. So it could have one or more solutions. Could have one or more solutions. It could have no solutions. But then it could also have infinitely many solutions. Now the graph of a system that has one or more solutions, if I were to graph that, what you would see on the graph is you would see intersection points. So it might be one point, might be more than one, kind of depending on what types of functions are in your systems. Now, if we're doing linear systems, we would only have one point. But if I had a linear and a quadratic, like a line and a parabola, I might have more than one point of intersection. Algebraically, what that will look like is you'll get a number like x equals 3 and y equals 4. Or you might see your answer written as an ordered pair, 3 and 4. That's what it would look like whenever you're solving the algebra problem. For no solutions, if you look on the graph, what you'll see is that there are no intersection points. And if there's no intersection points, you'd be a picture like probably if they're lines, parallel lines. Let's see. And if you are solving this algebraically without looking at a graph, which is what you'll be doing most of the time in this section, you'll end up with something, with some kind of number sentence that doesn't make sense. Like you might have 5 equals 0, which is a false statement. 5 does not equal 0, that is false. So you would write no solution, or you could say, have the symbol for no solution. Then it's also possible to have infinitely many solutions, means that there are a ton of x and y pairs that would make all equations true. So what that looks like on a graph, it looks like the same line being graphed on top of itself. And algebraically, when you're solving that, you'll know it's infinitely many solutions if you get a true statement, like you might get 3 equals 3 or 0 equals 0. Those are true. So you would write infinitely many solutions. There's no abbreviation for that. So don't even try to draw me an infinity or anything. Infinitely many solutions. So you would write this as your answer for that one. All right, so now in this video, we are going to practice substitution and elimination methods. So when you're solving, some examples are better set up. We're going to do example 1. Some examples are better set up for substitution, and other examples are better set up for elimination. So let's talk about substitution first. And a hint to me that I should pick the substitution method is that you look at the equation and you see a variable all by itself, or one that you could isolate easily. So with substitution, you need to isolate a variable. So I'm going to isolate the y here. So I'll have y equals, I'm going to subtract the 2x on both sides. So y equals negative 2x minus 1. Then I'm going to take what I have for y, and I'm going to substitute it in for the y in the second equation. So if my second equation is 5y minus 6x equals 7, I'm going to substitute in for this y 2x minus 1. So what I'll have is 5. I'm going to replace the y, so I'm going to bring everything else down. Negative 2x minus 1. And then I'm going to solve this equation. So distribute the 5 so that I have negative 10x minus 5 minus 6x equals 7. Negative 10x minus 6x is negative 16x minus 5 equals 7. I'll add the 5 on both sides. Negative 16x equals 12. And divide both sides by negative 16. X is going to be negative 3/4. And it's so exciting to think, okay, I got an answer, I'm done. But don't forget, this is a system of equations. And so our solutions are points. Solutions are points, right? And points have x's and y. So I need the x and the y value. So to get the y value, I'm going to take the negative 3/4 and I'm going to substitute it in for the x in my equation for y. So I'll have y equals negative 2, but instead of x, I'm going to substitute in that negative 3/4. So now I have y equals positive 6/4, which is 3/2, minus 1. And 3/2 minus 1 is 1/2. So then you might see your answer written like this with negative 3/4 and 1/2, or you might also write your answer as negative 3/4, comma, 1/2. So that's what my solution is. Now, I'm going to erase that because now I need to talk about elimination. Okay, so now let's talk about elimination. For elimination to work out, the first thing that you need to do is you need to stack your equations. So when I say stack your equations, I mean you want the x's to be over the x's, the y's to be over the y's, the equal signs over the equal signs, and the constants over the constants. So everything needs to be added, or stacked. After that, you want to multiply. I'm going to mute so you don't have to hear that every time I switch colors. You can either add your equations, or you need to maybe multiply so that you can add your equations to eliminate a variable. So I'm going to summarize that by saying find a way to add your equations to eliminate a variable. So right now, if I take the equations how they are, and if I just add them straight up, I'll get 9x plus 6y equals 8. And I still have an x, I still have a y. That's a problem because I have not eliminated any variables. I still have an x and a y. Okay, so that's done. So then I need to try to find a way to make it so that I can add them. Well, I'm looking here and I see a 3 and a 6. And now I notice if I multiply the top equation by negative 2, now I have to treat all sides of the equation equally, so I need to distribute that negative 2 to everything. But if I multiply negative 2 by everything, I'll have negative 6x minus 4y equals negative 2 times 5, negative 10. And now, if I add these equations together, the negative 6 minus 6, that cancels. I get 0. 4y minus 4y, that cancels or adds out. I get 0 equals. And then 3 minus 10, negative 7. Now, wait a minute. Is 0 equal to negative 7? No, that's false. And since it's false, that means this system has no solution. Now, if you feel like you've got a pretty good handle on substitution and elimination, I'm going to say you can go ahead and go to the next video. But I'm going to go ahead and work out a couple more examples because you guys were starting to request more examples in the videos. So if you want to, go ahead and move on. Otherwise, stay tuned. Okay, if you are here for extra practice or extra examples, if you turn to page, what page is this? This is page 46. There's a couple more examples for substitution and elimination. So remember, if I want to work on substitution, then I want to look for systems that have a variable that's already isolated or one that would be easily isolated, meaning that's by itself. So 16 is like that. 17 is already isolated. So that tells me 16 and 17 would be really good problems for me to apply the substitution method. I'm going to work out 16. On 16, x is solved for. So I'm going to take the expression for x and replace the x in the other equation. It's really important that you replace x in the other equation. So I'll have 3 times 2y minus 5, then bring everything else down. So bring down this minus y, bring down the equal sign, 5. Then I can distribute the 3, 6y minus 15 minus y equals 5. Combine like terms, 6y minus y is 5y minus 15 equals 5. 5y equals 20. And y equals 20 divided by 5 is 4. So I get a y value of 4. But don't forget, you've got to find the x because our solutions are points here. I've got an x and a y in the problem. I'm going to have an x and a y in my answer. So I'll use the original equation for x, and it tells me that x is equal to 2 times y minus 5. So x equals 2 times 4 minus 5. 2 times 4 is 8, and 8 minus 5 is 3. So the solution to this system is 3, 4. Okay, now we'll do another elimination one. So let me clear the ink here. Okay, let's look at number 18. And I notice all the variables are already stacked for me. So that tells me elimination might be a good choice here. So let's look at this. I need to figure out a way I can add my variables so that one of them are eliminated. Because if I add them right now, I get 3x minus 4y equals 8. And I did not eliminate anything. I still have an x and y. So I don't want to do that yet. But I noticed that if I multiply the top equation by negative 2, then I'll have negative 2x, which will cancel out with that positive 2x. And then I can eliminate the x. So distribute negative 2 to everything. Plus 6y equals negative 2. I'm going to add my equations together. 2 minus 2 is 0. Negative 1 plus 6 is positive 5y. You don't need that plus, but I had already committed. Equals 7 minus 2 is 5. Divide both sides by 5. We get y equals 1. Now I need to get my x value. So I look at my top equation. You can use the bottom, but for me it looks like the top might be faster. So I have x minus 3 times y, but we solved for y. We said y is 1 equals 1. Again, I'm pulling from this equation. So x minus 4 equals 1. Add 4 to both sides. X equals 5. So the solution to this system is 5,